Hello, this is Alan Folmsby here. So this is about experiments for physics. I've made up some theories of theoretical physics, but still I want to connect it all to experiments eventually. And today I'll be featuring some videos of the Maui Solar Observatory up on the volcano, and also I'll be focusing on the new periodic table of nuclear structure. And I would like some experiments to confirm the shapes of the various nuclei. This is on top of Haleakala, Maui. The observatory is coming into view in 3 seconds or so. "10,000 feet above sea level. There's the Air Force Observatory for space junk flying around there. And some tiny observatories. And on the left is the new Solar Observatory. It's pretty big. Aloha from Hawaii. It's a cold day in February 2020. Got down to about 62 last night. I had to put on clothes and everything this morning. 2 shirts, socks, a hat. Oh, where's my hat? Oh, well, it's warmed up a little bit now anyway. So these experiments I'm going to talk about are just proposed in terms of experiments. Some have already been done, but the theories that the experiments were made to confirm are not always right. So I'm proposing new theories, and we could look at old experimental evidence or have some new experiments done on the International Space Station, for example. So let's go to the PowerPoint slides here, and you can see the experiments list. All right, here's the PowerPoint slides here. Oh, let's see. So when you get up on top of the mountain here in my backyard, you can see the big island of Hawaii. And this is what it looks like on a volcano over there called Mauna Kea. And on the right top section, there's little black dots on top of the snow. Those are the observatories on top of the big island. And then on this little island here, there's also some observatories here. Now oh, I better stop this. It's automatically going forward. I'll start over again. Hi. I have a Master of Science degree in electrical engineering, and I have appointed myself to be a theoretical physicist. And you can believe what I'm saying or disbelieve it. Doesn't matter to me. Here's the new periodic table of nuclear structure. We're going to be looking at this in detail. I've arranged it into rows and columns. So the rows are called the periods, and the columns are the groups. And in this picture, there's 32 groups. And you see that some of them have kind of a pear shape, and some of them are not. They're just almost symmetrical squares. And we'll be going back to this in more detail soon. So the pear shapes, these pear-shaped nuclei, it's called the nuclear octupole deformation. So there's already been experiments done on radon, radium, and barium. and they've seen the actual pear-shaped. And an earlier video I showed has these things. And they have very vague-looking pear shapes. But let's look at the periodic table a little bit closer. I'm going to swing the camera around to look at this. Okay, it's almost ready here. Let's see if we can zoom in on some of these things. Oh, there it is. So as you can see, there's some almost square-looking nuclei of elements. But if we pull over to the left, you'll see barium, for example. And here we begin to see the pear shapes of the nuclei. Barium, you see it's octupole deformation. The top is a large part, and it's really armor against being destroyed. These are the surviving nuclei from long ago. These have the cube at the center in red of protons and neutrons, and the black ones are protons and neutrons, and the blue is protons added on top of foundation elements. So they have like colliders. Maybe the Large Hadron Collider, for example, looked at barium and also looked at radium and radon. I'll just show you those here. All right, there's radon 220 on the right. That one was tested at Collider, and it has a pear shape. It doesn't show as much detail as this. It's about 50 times less magnification as this theory. But experiments hold a special place in physics beyond theory. That anything I say of theory has to be either correctly shown in experiments or just maybe it's right, maybe it's wrong. So there's radon 220, and these are foundation elements. All of the noble gases don't have any of the blue dots for protons because these are just the foundation elements with a simple cubic lattice in red of protons and neutrons in the center. And the 6 faces are covered by small pyramids of other protons and neutrons. And they're not distinguished here. All are created equal. All are treated equally. Protons or neutrons form a silhouette of the nucleus regardless of charge. And we'll talk about the charge distribution a little bit later. So the experiments should be extended to all of the elements. And now we have this periodic table in theory. We could see that what are you shooting for in the experiments? What is the expected shape? All right, so I'll just go back to this periodic table briefly here. And so here's the expected shapes in theory for every nucleus. There's 118 elements in the periodic table. You see that at the top is just the tiny elements, and then iron starts a series with the cube has 3 layers in it. And this theory is based on iron. And since iron has such an excellent magnetic property, it was relatively easy to put together the shape of the nucleus that's proposed with the 2 loops of magnetic apparatus. So another type of experiment is the microgravity experiments in the space station. For example, we could assemble a cubic lattice in 0 gravity and show that when all the faces, 6 faces, are covered by little pyramids, that it's stable. And that using, for example, air pressure to pull together the nucleus in the experiment, we could show that incremental elements are formed by additional protons and neutrons falling into the lowest pits on the mock-up of the nucleus. So another type of experiment is to show the electron-proton pair is a real thing which physics should begin to recognize. In standard physics, they consider electrons to possibly be free electrons, not paired with a proton, like an electron gas. And that only in atoms, for example, is there a pairing of an electron and proton. But in my theory, every proton is paired with an electron. Now, under this theory, I've speculated that antimatter is really just matter with the reverse dimensional flow in this pair. So instead of a time-like dimension coming out of the electron, it will be going into the electron from the proton. And the space-like dimensions, instead of going into the electron, they'll be coming out of the electron. And that's what makes the antimatter show the opposite charge. Now, another thing is that this pairing is deterministic, but it can change. For example, during a photon emission, you could have a new pairing. The electron could go and become loyal to a different proton. And that could usually involve a photon being absorbed or emitted. Now, there's a phenomenon in physics called the Bremsstrahlung radiation, where a photon would be emitted when an electron is accelerated in a curve, for example. And this is, in this theory, due to unpairing of that electron from one proton and pairing with a different proton. And that's during that curvature that you see. So experiments could be done to show that this is correct. And there's no photon emission for electrons curving around when they're paired. So like if an electron is curving around in a bar magnet, for example, no photons are given off in many cases. And in an atom, no photons are given off usually, while the electron's curving around to different positions. A separate experiment is about the motor maximum speed. An electric motor, you'll find that you can buy these things for $1 or $10. And the current, electric current that goes through the copper coils in the motor are going about 1 millimeter per second. That's a common electron speed, 10 millimeters, 0.1 millimeter, in this range. And yet the motor speed is going maybe 50 meters per second or something. It's rotating at 1,000 RPMs, 10,000 RPMs. Even though the electrons are only going 1 millimeter per second, the coils are going almost 100,000 times faster than the electron. So if you take the electron speed and divide it by the electric motor speed, you'll find that in the limit, the ratio approaches the permeability of free space, mu, which is 1.2 micro per meter. When you're looking at it in 8 dimensions, the ether and the meter are a length-like and a length. So we could easily do experiments for that, just with off-the-shelf electric motors and simple calculations, showing that it never exceeds that. So if the electrons in the coil are going 1 millimeter per second, you can never go, the motor can never go faster than about 800,000 times that fast. Another set of experiments is concerning the quarks being obsoleted. There's many old experiments that were done in the past, but they were done to confirm the quark theory. But we can use the old experimental data to evaluate this new theory also. Or new experiments can be planned. Now, quarks were proposed because of the 3 jets that were seen coming out of collisions. And I'm saying that they're not quarks. They're just a reflection from a mirror in the proton of 3 space dimensions, I speculate. Now, another experiment we can do easily is that the paramagnetic elements come in 2 types. There's some heavier elements that have rings of protons, like terbium and dysprosium. They follow after gadolinium in the periodic table. And then a second type is elements without rings of protons, like lithium and oxygen. They're paramagnetic, but they don't have rings of protons. And the way you can do the experiment is just that terbium, for example, could become a permanent magnet at low enough temperatures. On the other hand, lithium will never be a permanent magnet in any experiment. So it's easy to do that experiment. Another experiment is concerning the neutron powers. What good is a neutron anyway? Here's what it is. During a fusion collision, the neutron rotates 2 protons by 90 degrees. So instead of an incoming proton slamming into a second proton, as it approaches, the neutron will rotate both of them by 90 degrees, diverting the velocity into a different direction. So they're orthogonal to the direction they used to be. And therefore that cushions the blow as the collision occurs. Another power of the neutron is for the expansion of the universe is due to a lack of neutrons in the hydrogen element. So there's a lot of deuterium that has a proton and a neutron, but there's also hydrogen which just has a proton. And under the 4-dimensional theory of that, the one dimension that used to go to a neutron is now just not going to a neutron. It comes out of the hydrogen and makes the universe expand. So another thing about the neutron powers is that the ratio of A over Z is approaching 8 over 3. A is the mass number, Z is the atomic number. For example, for iron, A is 57 protons and neutrons, and Z is 26 protons. But as you go to heavier elements, this number approaches 8 over 3. And that means that there's 1.666 neutrons per proton, 1 2/3. So this was seen as I built up the pyramidal cube for heavy elements. Let me focus on the heaviest of all, oganesson. All right, so this is element 118, and it has a mass number of 294. So as you take the ratio, you see it starts to approach 8 over 3, A over Z. But this is for a cube 4 element. It's unstable, and the pyramids on the 6 faces are covering and armoring it. But you can go to a cube 5 in the center with a bunch of with 4-layer pyramids, and eventually you'll get up to, as I was saying in this slide, 799 is A, and 298 is the number of protons. Notice how that approaches 800 over 300, or 8 over 3. So this theory will help experimenters by setting a goal, a proposed goal, and to confirm it or to show it's just not true. All right, so I'm looking at the messages now on the side here. I see there's text messages coming from Rahil Sahim. Hello. Oh yeah, it's really cold here. And you want a link to the table of the periodic table. Yes. So let me tell you where the table can be obtained on the internet here. All right, so my website's called pyramidalcube.blogspot.com. And there you will be able to pick up that new periodic table. So I'll just write that down here. pyramidalcube.blogspot.com. There it is. And you can get the latest version I just finished up yesterday with all the rows and columns aligned correctly. All right, so going back to the PowerPoint slide here. Another type of experiment is that the proton has a mirror inside of it. Instead of quarks, each proton has a mirror at the center, and it's called negative infinity. So that the lowest place in the universe is inside of you, the center of a proton, negative infinity. The sky above you is at positive infinity. So in terms of power, I'm saying that cryogenic tests to see if my prediction of the limiting 2.5 electron volts per second would be the replenishment power due to gravity that's available. And gravity power limits the average power of photon emission. There's spontaneous emission or stimulated emission, and at very low temperatures it would be spontaneous because of gravity. And the peak power is limited by Planck's constant divided by 5 nanoseconds squared. That's the 2.5 electron volts per second. And on the average, gravity is 10 to the 18th times weaker power than this peak power that I'm discussing here. So that any one atom is not able to continually emit photons at a high rate at low temperature. Is limited by gravity. Also in this experiment, I want to show that catalysts in the nucleus have a hook shape. Platinum, I've showed you in a previous presentation, has a hook of protons surrounded by a ring of protons and an axis. Also vanadium, in a more simple shape, also has the hook, the ring, and the axis. The charge distribution in a nucleus has the new theory, and the proton allocation in this theory has a hook shape for quite a few different elements, so there's various catalysts, and some elements are not catalysts for some reactions, like iron doesn't have a hook. It has two coaxial rings of protons. Or gadolinium also has these, as you can see in this picture here. So that's the gadolinium nucleus mock-up. And it's shaped almost exactly like iron. It's just it has 18 protons in each loop, but iron only has 12. All right, let's go back to the PowerPoint presentation here. All right, so it would be nice to have experiments. I'm not going to go into too much detail here on the experiments, but some are catalysts, some elements are not catalysts. And the goal is to eventually make an electric generator using new physics. Now, in the new physics, there's eddy currents for magnets and co-eddy currents also, as proton currents are flowing in the same RPMs as the eddy current. So the electrons are paired, and the experiments could be done with electromagnets or with iron bar magnets. And we could be measuring the velocity of electrons in eddy currents, and this will be showing how fast the proton current is going in gadolinium or iron. Now, you might have noticed that you look at the sun, there's a growth of magnetic field lines. And that's due to the velocity of electrons moving in a ring. And the length of this B field flux coming out of the sun can be compared with the velocity of the ring current to show how growth occurs. That the ring current is moving constantly, so the magnet time dimension is growing longer and longer, and that's what you see on the sun. And also experiments can be done concerning the absolute zero temperature, which I propose is limited by gravity. That as you try to refrigerate things down to lower temperatures, you're fighting all the power of gravity in each proton. Also, diamagnetism is similar to gravity in that it doesn't matter what temperature you're at. Really, diamagnetism is temperature independent. And another experiment that can be done is about superconductors should be flat, not tall, because there's only two dimensions connecting each proton to each electron. And that's why it's flat. Superconductor materials, you'll notice, are like ribbons, very flat conductors, superconductors. But if you rotate them 90 degrees so they're tall, that would be an experiment showing that it doesn't work as good for tall superconducting wires. And also the Weber definition is being explored, and the experiments can show and confirm that there's a quantized number of lines of flux. It's not like pouring a gallon of milk over an experiment where a homogenized liquid is filling everything. No, it's lines of flux passing by per second. And a Tesla is a Weber per square meter for the B field. And you can see in my notebook what the formula is. In fact, I'll just put that on camera for you here. All right, here's my notebook from 4 years ago, 3.5 years ago. A Weber is equal to pi over mu zero, permeability, H, the magnetic field intensity, multiply the volume of proton, Coulomb constant, divided by the charge of an electron times 5 nanoseconds times the gravitational constant squared. So anyway, if you just multiplied all these things together, you would find that it comes out to 866 billion lines of flux passing by per second. And if that's in a square meter, then that's 1 Tesla. And then there's exclusion principles, and for example, the Pauli exclusion principle for quantum numbers NLMS. There's additional principles of exclusion for the positions of electrons, and I claim that they are quantum states. And magnets make a vortex that excludes some of these freedoms for electrons, and it gathers together lines of flux. So I'm proposing a Pauli generalized class of exclusions phenomena. So mass defect. When fusion or fission occurs, you find that the mass defect, mass changes. E equals mc squared is expected. But what about the precision and errors in E equals mc squared? So like if you're fusing together lithium or fissioning uranium, how precise is E equals mc squared? Because I propose that this mass defect is really a shadowing in the nucleus. Under the mass equals area theory, the mass is an area that is being shadowed by other areas. And so the experiments can be done for that. So let's do a little bit of looking at some of the videos from on top of the volcano last week. There's the snow on top of Mauna Kea. And also Mauna Loa is nearby there. In fact, there's like 5 volcanoes in here. Kohala, Mauna Loa right here, 100 miles away. And also you could see that the observatory is 100 miles away from those volcanoes. The Maui Solar Observatory, they're doing experiments for me and you. And I want them to do more for me. Oh, there's Mauna Kea. Here's Haleakala and the crater of the volcano last week. There's a little bit of ice up there, 10,000 feet. You can drive right up to these observatories. You'll see the Air Force Observatory here, where they look for space junk. It's that flat observatory is the Air Force, where they track the space junk and see if there's going to be collisions. And then on the left, you'll see the new Solar Observatory, costing like $250 million or something. And I think it's called the Daniel Inouye Observatory. And that is the experiments we're doing here on Maui. Not me, but my friends. Well, not friends, neighbors, let's say. In units of measure, experiments can be done to simplify these units of measure. The H field is really a velocity. H is the Maxwell's equations magnetic field intensity. They claim that it's amps per meter. But what does that mean other than just fitting into a formula? It means a velocity, because amps is coulombs per second, and a coulomb is an area. And so if you cancel out factors, you find that the H field is the velocity. Now the magnetic B field, the magnetic flux density, turns out to be a frequency per second. The B field is the number of lines of flux per square meter per second. And experiments can confirm these abstract units of measure, and we don't have to continue using Maxwell's mysterious units of measure of amps per meter or volt second. We can go back to simpler things like velocity and frequency. And the stability of a static nucleus. Now, some unstable elements can be simulated. for example, by balancing 3 basketballs in a contest. Imagine holding 2 basketballs where you're controlling the bottom one, but there's one balanced on top of that. That's easy to do. Now, you could try balancing 3 vertically stacked basketballs by just rotating the bottom one, moving it around. You could conceivably balance 2 more basketballs on top of that, and it would seem almost unstable. But an expert, I believe, could do that. But it's impossible to balance 4 or 5 basketballs on top of each other. And what this is about is the instability of cube 4 at the core of technetium and promethium. Now, gravity, I'm proposing that electrons do not cause gravity. It's caused by protons and neutrons. The volume of protons and neutrons is affecting the volume of the space outside of the protons and neutrons. And in opposition to general relativity, I'm saying that energy does not cause gravity because the energy is only associated with matter. Photons do not cause gravity. For one thing, photons do not contain energy. They transfer a velocity-like property. The energy changes are in the atom emitting it or the atom absorbing the photon. And it may be possible to do experiments someday for that. Now, time dilation in molecular chemistry is seen a little bit in the, say, a muon is coming from outer space and hits the atmosphere. It rapidly decelerates, and that extends the half-life of the muons from like 22 microseconds out to a much longer time so they can reach the ground. Another piece of evidence I've noticed is that there's a galaxy called M87 with a jet coming out, and I call it the time fountain, and that any neutrons traveling within that jet have their life extended from 15 minutes to millions of years. And this brings hope for good times for us, the molecular animals. Now, the Coulomb repulsion experiments can be done. So in the olden days, the Coulomb force was like gravity, 3D, same in every direction. However, the new theory of pairing of a proton and an electron and the exclusion of a pair excluding other pairs. Now, this uses 2 dimensions instead of 3 at the very small scale. So one experiment would try to ask the question, can one proton repel 4 protons while attracting 5 electrons? I say, no. You should be able to distinguish the 2-dimensional nature when you attempt this kind of test. Now, the nuclear charge distribution can also be experimented with. And here's uranium, the nucleus of uranium, yellow protons and gray chocolate spheres of neutrons. And protons tend to form lines of protons outside of the cube. Inside the cube, they repel each other. Protons repel protons. And so there's 2 classes there, where the cube is a primordial remnant from very early eons, and yet the faces are covered by later additions. And that's why protons can line up in lines. In fact, they're forced into lines because they're paired with electrons, which are excluding each other. And now, experiments in thin films for spintronics involve, for example, gadolinium. And it has 18 protons in its rings in the nucleus, whereas iron has 12 protons. Now, in this Spintronics book that I have on page 239, I can't show it to you because it's copyrighted, but I can give you the title here and authors. Okay, I'm holding it in my hand now here. And it's Spintronics for Next Generation Innovative Devices, edited by Katsuoki Sato and Eiji Saito. And in this, on page 239, they're showing how an alloy of iron, cobalt, and gadolinium can be used to demonstrate that a quick pulse of light can reverse the magnetization polarity. But only if gadolinium is 25% of the alloy in the iron cobalt amorphous film. What a coincidence. Gadolinium has 18 proton rings, iron has 12 proton rings, and this phenomenon happens at 25%. I think there's some relationship here between my theory and that experiment. And that the goal is to make a generator, a new physics based on these new radical ideas proposed by a master of science in electrical engineering. The generator of electricity is the goal. All right, so that's the end of today's presentation. And my name's Alan Folsby. I have a Master of Science in Electrical Engineering. And I've started this Maui Theoretical Physics Laboratory, and I promoted myself to be a theoretical physicist. And team building has started. So thank you very much. I'm going to end this very soon now. Goodbye.